The ice ages are in fact caused by an internal mechanism. It is self-generating. I'm Richard Klein. I come with an interesting array of qualifications. I'm actually, by training and education, I'm an engineer. I taught for 30 years at the University of Illinois in Urbana-Champaign. It was a blessing to be in that position because I was afforded three things. I was afforded a reasonable way of making a living. I got to live or work among very talented students. And the third thing is that I was free to pick and choose whatever I wanted to do in terms of my research. And so that allowed me where my boss and the department head didn't worry about what I was doing. They just let me be on my own. And so I was free to pick and choose what I wanted to research as a mechanical engineering professor. My specialization within mechanical engineering is the mathematics of feedback control systems. I am a control systems engineer. And as a result, I tended to focus on things. I became an applied mathematician, and I focused on mathematical questions. Early on in my career, I joined the University of Illinois in 1968. But early on, I was attracted to things that wiggle and shake and move and otherwise are not explainable. And that led me to looking at the question of what is the causation of ice ages on Earth. Few of us will argue, most people accept the fact that approximately 12,000 years ago, that is when a great melt occurred, and what we refer to as the Wisconsin Ice Age, the ice sheets receded, and the Earth rebounded quite suddenly. The people on Earth really don't understand, in my opinion, the deeper picture, and that's what I wish to get into today. And so the topic we're going to discuss is the causation of ice ages, ? And to proceed on from that. Early on, I observed an ice core recording that came out of Greenland, and at that point, I made a hypothesis. I said to myself that this is something strange that's going on, and I just concluded as a guess that the causation of the ice ages would be an internally generated mechanism within the Earth's climate system as opposed to an external driver argument. Neil Armstrong said, geologists have a saying, rocks remember. And so if we think of Neil Armstrong stepping onto the moon or this type of thing, whatever he did in his career, if he would come upon a rock, he fully understood the fact that that rock was there for a reason. There was a historical basis for what caused that rock to be there. We have to give tribute to the rocks of the Earth, and that scientists and geologists who have studied this have then been able to reconstruct the story as told by rocks of the Earth's atmospheric record. For example, some sources show a plot, and we have it here going back 5.5 million years, and it's a reconstruction of Earth's temperatures. And we will notice that I have arbitrarily divided the Earth's temperatures into three regions. The three regions being alpha, I call them alpha, beta, and gamma, starting 5.5 million years ago, going up to approximately 3 million years ago, I call that alpha. Then from the time from 3 billion years ago to 1 million years ago, I call that beta. And lastly, the Earth's temperature record in the last 1 million years, I call gamma. You will notice that in this particular chart, and even in my discussion, I don't get real excited about or worried about the last 5 or 10,000 years. That is a separate issue. We can talk about that issue at some other juncture or some other day. And so we're looking at alpha, beta, and gamma. When you look at these records, we notice that in the first region, alpha, it is relatively warm. There is no dominant cycle that we're able to see. But then 3 million years ago, somehow the Earth, it got a little bit cooler, and the Earth went into a very unusual transformation. That is, the Earth started displaying a strong cycle. It has a 41,000-year period, and also along with that cycle, we also see a general downtrend or dropping of the Earth's temperature. And in the last 1 million years, we see a dramatic shift from going from a 41,000-year cycle to a longer cycle, and that cycle is 100,000 years. Duration is the period of that cycle. And furthermore, so that we have very solid evidence that the Earth has undergone in the last million years, has gone through approximately 10 dominant swings in terms of temperature. And thus I'll say we believe, we means the people who study this, the Earth has undergone approximately 10 periodic ice ages. And so the question comes up now as to what caused that, in particular, the focus in the region alpha, the last 1 million years, what was the causation of the Earth deflaying this 100,000-year cycle? Now, it is true that other people can argue other records, but I accept this record as being true. I am not going to argue it. The literature is solid, and I'm going to just accept that. And if you want to argue that the Earth is flat or that it was constant temperature and never changing, fine, you can go ahead and argument, but it's my belief that any person entering into that argument from that viewpoint will lose the argument. I am accepting or asserting the fact that the Earth has undergone approximately 10 periodic ice ages, and that the question comes up now, how can we explain the causation? What mechanism caused that? What is going on? And please appreciate the fact that as a control systems engineer, a dynamic systems quote unquote expert, this really attracted my attention. Approximately my first observance of it was in approximately 1971. That's over 50 years ago. I submitted and published my first peer-reviewed paper on the topic, and that appeared in June of 1972. And so I can say that I am not a Johnny-come-lately on this topic. I have been intrigued with this question. I have studied it. I have researched it. I have written about it. And that has been going on now for 50 years, half a century. And there's a saying within science is that the person who has the greatest doubt about the validity of a theory is the person who came up with the theory. The last thing that I would ever want in the world is to publicly proclaim some type of theory and have it later being proved to be false or in error. And so that to guard against that for 50 years of my life, I have tried to disprove my theory. And at every time, at every juncture, instead of being able to find that, aha, Richard, finally, I've proved that you're wrong, you can now go to bed at night and rest, I found that the theory became reinforced. And the theory that I'm talking about is that the ice ages are in fact caused by an internal generation. It's an internal mechanism. It is self-generating. In the 1980s, we came across a phenomenal research results were published, and it concerns Lake Vostok in the Antarctic region. And Lake Vostok is a large, deep lake in Antarctica. That particular lake is under a cap of 2.2 miles of ice, and that a combined scientific expedition of persons from the Soviet Union, from France, and the United States did an ice core drilling on the Vostok ice core as ice cap. And in the process, they were able to extract the 2.2 miles of depth, a little over 10,000 feet of sediments of ice. They were able to take those cores out. I presume they transported them to laboratories elsewhere on the Earth, and they analyzed that. And as a result, we came up with, I will now call the Vostok record. And the Vostok record, as we show here, and this is based on an internet source, is that the upper graph shows a temperature history, clearly the measure of the temperature of the Earth. The second, or the middle graph we have, is the carbon dioxide concentration in the atmosphere. And the third, of the lower plot, shows the concentration of just particulates. And now we have this record for approximately 420,000 years. The record is absolutely precise and clear. We are just seeing a phenomenal dynamic system here at work. Even a blind person could look at this and feel with his fingers that the Earth clearly is experiencing periodic ice ages. We're seeing a periodicity. And we now have to ask the question, again, what is the cause? what is causing this ice age? And over the years, we have to go back and now think one of the early researchers who studied this is a Serbian mathematician. His name was Milankovic. I hope I'm pronouncing that correctly. He lived from 1879 to 1943, and for a 30-year period from 1911 to 1941, Milankovic worked as a mathematician attempting to correlate the wobble of the Earth as he calculated or had calculations as related to what the record of the ice age had been revealed as determined by rocks. This is actually long before the Vostok record was made public, is when Milankovic did this research. And I just want to make the observation that, and I don't recall what he really concluded, whether he was right or wrong in his conclusion, but I will say this, that if you do observe ever in two records of correlation, the correlation does not necessarily prove causation. And so that early work was done by Milankovic, the Serbian mathematician. And since then, it's my understanding that approximately 60 different theories have been proposed. And the vast bulk of these theories, in terms of theories meaning an explanation as to why we have had periodic ice ages, the bulk of these explanations have always been rooted in the one basic assumption that there's an external driver that is making the Earth get warm and cold and warm and cold. And the usual culprit, or the usual suspect, is, of course, sunspots or variations in solar insolation. Another observation is, as Milankovic attempted to show, that it was related to the wobble or the orbit of the Earth. Another thing that they will try, for example, is that it's asteroids or meteoroids, or this type of thing. We also have geological explanations. Some person will argue that it's periodicity of volcanoes, that the volcanoes erupt in a periodic fashion, and thus that causes the rise and fall of the Earth's temperature in a periodic fashion. Another one of the theories, and it's one that I call it one of my favorites, and I'm doing that sarcastically, is the fact that it has been argued that the Tibetan plateau has raised and lowered itself in a 100,000-year cycle. And because what's interesting about Tibet is located in a region actually quite close to the equator, and yet because it's so high in altitude, elevated, that it is above the frost line, therefore there's very little vegetation in Tibet, and furthermore, it can be subject to, when it's at high altitude, to ice formation, causation, thus having a high reflectivity. Those are some of the interesting things. And so of the 60 theories or so that have been proposed, again, the vast bulk of them have all been related to, argued based on external drivers. And I'm going to bring that into very great question. There was one other study that I know of that takes the opposite view, that the Earth's periodic ice ages are internally generated. And there was a paper published in 1976 by two Russian authors. Their both last names are Sergin, but it's Sergin and Sergin, 1976. That work also appeared again in a second article that appeared in 1978. And Sergin and Sergin argue that the causation of Earth's ice ages is explainable as an internally generated mechanism. And they did at that time what is called an analog computer simulation, that is using electronic differential analyzers. We call them op-amps. In that time, that was a very popular way of doing computing. They did a study and they came out with the result. They had a simulation published that indeed showed a repetitive cycle. I want to make a couple observations. The first observation is that simulation itself is not a proof. That is, from a mathematician's standpoint, the fact that you can set up a bunch of circuit wires or computer code and cause something to happen, that does not necessarily prove that you are correct. Again, simulation is not a proof. The second problem that we had with the Sergin work was that they were looking for the 110,000 or 100,000 year cycle, and instead they got a cycle that varied anywhere from like 20,000 to 80,000 years, depending upon parameters. At that time in the 1970s, I attempted to take the Shivering work and recreate the computer simulation. I had access at the University of Illinois to what are called electronic differential analyzers. I'm very fluent in the use of electronic analog computers, and I was not successful in reproducing the Shivering results. And the dominant reason was that Shivering did not publish fully all the numbers that I needed, the gain settings, the potentiometers, the functions used mathematically. They were not published in the paper, and I was not able to do that. In the end, I have concluded that this, although I have very high respect for the Shivering work, it's the fact that they did not hit the target. And at this point, I'd like to now switch track a little bit and go to the point of talking about the thing called limit cycles. There's a phenomenon known within dynamic systems, in particular known nonlinear systems, whereby things will self-oscillate or generate. And mathematically, this work was originally, if not founded by, but it was supported to a great extent by a Russian mathematician, A.M. Lyapunov. And Lyapunov lived from 1857 to 1918. He was a student under the famed Russian mathematician Chebyshev, and Lyapunov did some phenomenal work. His doctoral thesis was published in the 1890s. And yet the knowledge of the Lyapunov doctoral dissertation and his work was literally unknown in the West until after World War II. And that's another story of it in and of itself. But what Lyapunov did, he devised a stability theorem whereby he came up with a concept called Lyapunov stability. And the actual theorem is not that useful. We as control systems people have done very little to exploit Lyapunov's theorem. But what is really important about Lyapunov is that he came up with the concept of a limit cycle. And a limit cycle is just a self-generating cycle within a dynamic system. And that the limit cycle has two properties. One property is that it will go to a particular frequency, and the second property is that it will go to a particular amplitude. We, meaning people that study nonlinear systems that cycle, we become very interested and intrigued by limit cycles. Some examples of limit cycles that we encounter in life, they abound around us. It's just that most people seldom realize, hey, what is going on? But probably the most classic that I want to talk about is the Old Faithful geyser in Yellowstone National Park. The Old Faithful geyser is a geyser that you, as a tourist, have been there, that approximately every 65 minutes, the geyser will erupt and spew out all the water, and it floods and impresses the tourist. It will then, once those vents of the geyser vacate themselves, it takes approximately an hour for the water to fill back in. Earth's heat core from underneath will then cause the water to boil, create steam, and again, the geyser will erupt. And I assert that the geyser, Old Faithful, is a limit cycle. And furthermore, we make the point that it is not externally driven. It is not driven based on sunspots. It's not driven based on what the orbit of the Earth is doing. No, it is strictly an internal mechanisms. The human heart is an example of a limit. I argue that it's in fact a limit cycle. It's a cyclical behavior. It's a mechanical mechanism from an engineering standpoint. And it will, if you're running or walking or whatever else you're doing in your life, your heart will undergo a normal rhythm, and it's a cyclical rhythm. And hopefully, if you're a healthy person, it has a very nice behavior. Other types of limit cycles are, for example, machine tool chatter is something that is a limit cycle. Another thing is if you take the famous thing of scratching your fingernails on a chalkboard. We used to have chalkboards in the old days, but you can scratch your fingernails on them or hold the chalk in an inverted position so it's pointed down. As you go down, you'll get a screeching sound out of that. And other types of limit cycles abound and exist, and they exist throughout nature. With that said, I'd like to talk about my particular hypothesis. I'm arguing the fact that the Earth's periodic ice ages are in fact caused by or explainable by a limit cycle argument, number one. The second thing I want to say is that I have to then identify what is the mechanism. If we look again at the Vostok record, the Vostok record has interesting questions, and are in fact so much evidence. There's so much data within the Vostok record. I argue that if you come up with any theory or candidate explanation as to why the Earth undergoes periodic ice ages, your theory has to be able to pass certain tests. And your theory has to be able to basically be compatible with the detailed record of the Vostok ice core. One of the most important aspects of the Vostok ice core is that when the Earth rebounds out of an ice age, it does not do so gently. The Earth rebounds in an incredible, brutal, rapid, abrupt fashion. That is, even though it takes approximately 90,000 years for the Earth to historically slowly descend into an ice age, it turns out that when it comes out of the ice age, even though it's not necessarily clear in the Vostok record, that rebound occurs in a period of approximately 5 to 20 years. It's an extremely abrupt reversal of coming out of the ice age. We also know in the case of the Wisconsin, the last ice age that occurred 12,000 years ago, approximately, that the Earth came out of the ice age in 3 jagged jumps, and they occurred over a very short period of time. And I argue now, this is just a test, that if your theory holds ground, your theory has to be compatible with the fact that the Earth will rebound abruptly out of an ice age. And I assert that external driver mechanisms such as solar spots, such as a meteor or a comet coming by on a periodic basis, or wobble of the Earth, these types of arguments, in my opinion, do not support an abrupt rebound. And therefore, I categorically reject all external driver mechanisms. Another test that we have is, why did the Earth undergo a change between the beta and gamma regimes a million years ago, of going from a 41,000 year period cycle to a 100,000 year period cycle? I again argue that if there's some type of cosmic astronomical clock out there that's ticking away, that if you're going to tell me that the entire universe changed what it's doing because 1 million years ago and we now went to a new driving cycle, I just don't buy it. You can argue it, but that's your choice, okay? Other things have happened. We know about when we came out of the ice age. We know, for example, that there was massive flooding. The Missoula River in Montana, the geologists can show this, had more water in it, a depth of over 2,000 feet of water, and it had more water in it than all the rivers on Earth today flowing. Geologists are able to show and establish the fact that there's periodic layers of deposits that normally would not be on the Earth's crust are here in layers. And we have to explain. Now, of course, for the people with quick answers, they say, well, that's absolute proof that the explanation is external, meaning asteroids came and impacted the Earth, and therefore that is why we see these strange deposits appearing. I reject that argument. I'd like to comment that the causation of ice ages is still an internal mechanism, and I'll give you an answer here in a few minutes. I want to switch track here and talk about Lake Nyos. And Lake Nyos is the lake in Cameroon, Africa. In the 1980s, you can Google that at your leisure, Lake Nyos, spelled N-Y-O-S. Lake Nyos, on a very calm August evening, erupted and flipped. And what happened when Lake Nyos flipped at the deep volcanic lake, Crater Lake, in one night, the lake overturned. And when it overturned, massive amounts of gas then came out of solution from the lake. That is the lake burped or degassed. And in the process of degassing, it released approximately 1 billion cubic meters of methane and carbon dioxide gases, that is, toxic gases. And as a result of that, it stirred up the entire lake. The lake developed a reddish-brown rust color. There was a wave type and an action whereby layers of sediment were then deposited on the nearby shoreline. And in the process of that eruption of Lake Nyos, it turns out that the cloud of gases, then being slightly colder than the surrounding atmospheric air, moved as a cloud down a valley. And in the process, it asphyxiated approximately 3,000 head of cattle and other livestock. And furthermore, there were 1,700 villagers who had been living nearby, and they were also asphyxiated at night. It has nothing to do with climate change and ice ages, but I bring it up because it's an example of a violent degassing of a body of water. And I will also say that when bodies of water, sure, like in North America, we have lakes about the Midwest. I know I used to vacation up in Minnesota, Lake Ida, in Lake Miltona. There are lakes in Iowa. There are lakes in eastern Oklahoma. Lakes and bodies of water will flip. And usually when a body of water flips, it will flip in a very violent, quick, sudden action. And with that said, so we've done a little homework here. We've talked a little bit about the fact that bodies of water can flip. And now I will make my assertion. I argue that the mechanism for the causation of periodic ice ages is that the Earth's oceans undergo an instability, basically a density inversion, and they will then flip and turn over. And I'd like to share that whenever oceans do flip and turn over, this is a violent event. It's a violent event because it's sudden. You will release all sorts of gases that had been formerly in solution. In my next life, I would like to be able to find or study or become a chemist to be able to understand the chemistry of partial pressures and all this, but it's very obvious. The evidence that we have is that when bodies of water flip, that they do so in a violent fashion and degas. And now to look in perspective at what I'm going to call the Kleinian theory of glacial causation is the fact that the Earth is in a limit cycle, that the Earth will slowly get cool. It takes 80, 90 to 100,000 years to cool off, to go into a ice age. It's also been referred to as a snowball Earth scenario. Again, I want to go back to the notion of being a control systems engineer and an expert in feedback control systems. It would always intrigue me that when I first studied the Earth and its climate, is that the Earth seems to have temperature-wise in its climate system so many positive feedbacks. And if we're familiar at all with positive feedbacks, we know that positive feedbacks reinforce themselves and they thus become unstable. And one example of a positive feedback is what's referred to as albedo. And albedo refers to the reflectivity of the Earth. It's well known and established that, for example, ice sheets and lack of forestation will increase the albedo, that is the reflectivity. And if you would ever increase the reflectivity of the Earth, you will in fact cause more energy to bounce away off of the Earth, solar input energy, and thus the Earth would become colder, thus reinforcing itself, increasing the amount of albedo. A second example of a positive feedback is essentially when it gets colder, the Earth will have less humidity in the atmosphere. And when the Earth has less humidity in the atmosphere, you have less chance from a probabilistic standpoint of water molecules clinging to a piece of dust and thus falling as rain. And so that as it gets colder with less humidity in the atmosphere, you will then have an increase in dust. And when you have an increase of dust particulates in the atmosphere, you will then have an increase in the reflectivity of those small little particles, I'm going to say, and actually in Brownian motion in the upper atmosphere, thus increasing the reflectivity of the Earth. And so I've cited now 3 examples of positive feedback, and there are others, but I always pondered, well, why does the Earth not go unstable? Why does it not go into a snowball Earth scenario? And if we go back and look at the alpha, beta, gamma record, gamma in particular, I would actually assert that what you're looking at is the 100,000-year cycle is the Earth for 10 times has attempted to go into a snowball Earth scenario, and yet something violently and abruptly causes that to reverse itself and to bounce out. And I argue that it is the fact that the oceans have become unstable and the oceans undergo a flip. And then the ocean degas. When they degas, you have carbon dioxide in particular and other gases that are released into the atmosphere. You have a mechanical breaking up of the ice sheets that have been covering large portions of the ocean. And this leads to a warming of the Earth and furthermore, a sudden warming of the Earth. I published a book on my thoughts. The title of the book is called Shivering. The title is a play on words because shivering is an involuntary reflex. You cannot cause or force yourself to shiver. And I argue that the Earth is indeed shivering because the Earth is involved in a argument or a struggle with regard to what its temperature is doing. I've had a wonderful time doing this research. Science can only prove very little about climate. And I say science is helpless in this topic. And science is helpless for the one reason that science is built on or predicated upon what's called the scientific method. You have a hypothesis about the world, you've observed something, you have a hypothesis that can possibly explain it. You then go to the laboratory and you set up an experiment. You drop an apple from a tree and measure how long it takes to fall. You drop 2 rocks off of the Leaning Tower of Pisa to see if the rocks will fall at the same time or if the large rock hits the ground first. That is called an experiment. And then you would take the experiment and evaluate it. Did it support or disprove the hypothesis? That's the third step in the scientific method. And the fourth step is that you would then publish your findings in some presumably peer-reviewed journal. And I would argue that science is incapable of answering the question of if my theory is right or wrong. And it can't do it because we cannot perform an experiment. That is, we don't have a laboratory that we can go into. We cannot change. I'll go and paint the Earth with asphalt tar and I'll change its albedo and we'll see if it works. They won't allow me to do that. I can't do it. And even if I could conduct an experiment, that we as humans are impatient. There are very few humans who are willing to wait 90,000 years to see if the next ice age comes and if the oceans flip as R.E. Klein predicts or has discussed. And the third observation that I want to say about the limitations of science, we like to worship the computer and say, we'll do a computer simulation. I want to assure you, first off, that simulation is not a proof. The second thing I want to say is that I'm a skilled computer programmer, used to be programmer, and I can virtually make a computer simulation prove anything that I want. And it all depends upon how I cut apart and fracture and lump the particular particles. We have so many particles on Earth. We have so many mechanisms that are complex. It is beyond the present capability of anyone to be able to say, I have done a computer simulation, and therefore I have proved that Klein is wrong or Klein is correct or whatever else. I, like all people, hope and pray that I'm wrong. I would like to be proved wrong because the worst thing that I ever want would be to ever have people believe a theory that is in fact false. It has been a wonderful time working. I've spent a half a century of my life studying climate and the causation of Earth's ice ages. You will notice that I have not discussed today, I have not discussed the issue, well, gee, Klein, what about global warming? What do you have to say about global warming? My statement is that all the discussion of global warming and the hysteria over it is entirely pointless and absurd because you have never answered the question. You haven't recognized that the Earth has undergone periodic ice ages in the last 1 million years. And furthermore, you have not come forward and explained why that causation has happened. And I would like to say about peer review and this type of stuff, I am distrustful or disrespectful of the meteorological climate community. And I don't respect them for the following reason. I believe they have failed. They have been an utter failure, and they've been an utter failure because of one obvious fact. They have never been able to explain Earth's ice age causation, and furthermore, they don't even seem to care. And it's hard for me to take climatologists seriously if they don't have the slightest clue as to what caused the predominant phenomenon of periodic ice ages on Earth. I've had a wonderful time, and it's very hard to see where this goes. I am hopeful that in the next 50 to possibly 500 years that I will be affirmed, or somehow somebody can conclude, hey, this guy, Richard Klein, he was correct. But if not, it's been an exciting study. And remember that science itself is based on the concept of skepticism. It is not a body of knowledge. Science is not somebody's dogma or theory. Science is a process. It is a skeptical process. The word theory comes from the Greek, means to observe. You observe the world and you then come up with a hypothesis. And that's what I'm doing. And I admit, even though I've thrown a hypothesis forward, I lack the ability to substantiate that hypothesis. If there is any hope in ever establishing it or verifying or validating that theory, I have to argue or suggest, or I believe that it will come about based on circumstantial evidence. If we have 10, 15, 20 different other pieces of discovered evidence about what the rocks tell us, that if that supports this, then that helps support the theory. I invite any of your questions and inquiries and responses, and have a wonderful day.
I would like to know if you've looked in detail at the work of Ralph Ellis about what he thinks about the role of dust in the ice ages.
First off, the gentleman you referred to, I am not familiar with his work. Therefore, I cannot comment in any direct manner. I also want to say that as you look at me here having a wonderful time, I happen to be 84 years young. I happen to also be legally blind. And as a result, I am very restricted regarding what I can do. I cannot look at things anymore. It's just an issue of being blind. I'm still having a wonderful time in life and so on. But I will say the following in terms of any other theory, that whether I am right or wrong, or whether this other gentleman is right or wrong, theories, the whole notion of science or the goal of science is to promote questions, to promote skepticism, to continue to look and to search. And the fact that we can argue about or suggest that, hey, the causation of Earth's ice ages is something internal, be it basically my argument is largely based on the oceans becoming unstable and flipping and degassing, or if it's the issue of dust, I think that the two things can be compatible with each other. When I go back to the alpha, beta, gamma, or if you go back and look at the Vostok record itself, it's very clear from my perspective as a control systems engineer, theoretician, mathematician, however you want to describe me, that it is a very dominant, strong record. And furthermore, if we look at the Vostok record, the upper graph is the issue of temperature. And it's very clear to me, yes, there's a little dancing and bouncing around and some change and some additional oscillation at a 21,000-year period. But what we're looking at is basically a sawtooth wave, and it's a very dominant thing. And within control systems, technology and theory and the culture of control systems, when you see a very rhythmical phenomenon occurring, we can be very confident of the fact that the mechanism is a very simple mechanism. It is not a complex mechanism. The explanation, there are very few what we call degrees of freedom. You do not need 10,000 or 1 million variables, and you got to look at every leaf and every banana tree on the planet and every wave and every grain of sand. No, that's not true. It's a very simple mechanism. And I assert that the models that we will eventually come up with will be simple models, can answer these questions and support or deny any hypothesis that's thrown forward, but it is clearly a simple mechanism.
Do you think there's anything we can be watching for in the oceans to figure out when the next flip is going to happen?
The question is, where do we go from here? What's going to happen? My particular take is that, first off, I don't get terribly worried about climate change or global warming. If I actually worry about the Earth getting cold, that is us meaning the inhabitants of Earth going back into in 90,000 years, or approximately that period of time, another ice age. And I see it from the standpoint of releasing carbons, fossil fuels, burning of fossil fuels, is that what's happening is that we have a chance of possibly fighting global warming. There may be a rise in temperature. I don't get very worried about it. I'd like to talk just quickly, because that triggers another thought in my mind, is that the hysteria of, oh, well, the ocean levels will rise because the Antarctic ice cap will melt and we'll all drown and woe is me and so on. I don't get terribly worried about that. In the last 12,000 years, we know that the Earth's oceans have risen approximately 400 feet. There used to be a land bridge between Asia and North America 12,000 years ago because the oceans were that depressed. And so that on average, for the last 12,000 years, the oceans have been rising approximately a third of an inch per year. I am not terribly worried about global warming. I'm not worried about oceans rising. And one reason being is that the bulk of the water that is now resting on land in the sense of frozen ice, frozen water, is in the Antarctic region. And as we've seen at Vostok, that ice cap is now over 2 miles thick. The ice cap in Antarctica has what we call a time constant, or has a time characteristic feature that you could go down there with a blowtorch and spend the rest of your life and 10,000 lives, and you will not be able to raise that. There's an incredible time lag, and I am not worried about it. So what your question turns out what to look for in the ocean. The one thing that I have not explained in my book, Shivering, is the actual causation of the flip. It's clearly a situation. It has to be an issue, if I'm correct, it has to be an issue of instability, but then what triggers the first grain of sand or the first bubble or the first flip of water molecule rising in terms of an inversion or a flip. And the flip could be one of two things. We could indeed be seeing a density inversion, because once the ice covers on large portions of the ocean become ice covered, then I argue that the circulation of the Earth's oceans then is altered and changes and is reduced. And therefore, if we change the circulation of the ocean, certain things happen. And then I'm arguing that the heat from the Earth's mantle, the Earth's crust, will come up and warm the lower portions of the ocean, and thus this creates a density inversion. But there's a second candidate explanation. The second candidate explanation has to deal with the supersaturation of gases. And it turns out that when deep water rises, the deep water is pretty well established, the fact it is very near, either at or near full saturation. Then as the pressure is reduced, then that causes a foaming or a discharge of bubbles. And so I'm just pointing out that I don't have an answer. I'm not a chemist, and we don't know. It's really hard today to go back and say what the Earth's, we know very little about the oceans under about 500 feet. I have a son, he works now has a doctorate in physics, and he works as an oceanographer. And he said even the U.S. Navy does not really concern itself with anything deeper than 500 feet. And we've got 5 miles of water in the Pacific Ocean. We know very little about what's happening, and we certainly don't know anything about what happened 1 million or 2 million or 8 million years ago. It's just a very tough problem.
I don't know if you touched on this already. Do you have any ideas what caused the difference in regime beta versus regime gamma with the 41,000 year cycle versus the 100,000 year cycle? What caused the cycle to change?
Yeah. Thank you, Tom. The question of the 41,000 year cycle, I do discuss this in the book Shivering. I argue, again, this is a hypothesis. My hypothesis is that because the oceans had a different level and there was a different amount of ice cap, I assert that it is a different ocean that is flipping. And I make the assumption now that when we are in the region gamma, that we are dealing with an ocean flip, which inevitably has to involve the Pacific Ocean, which is a very large ocean. And yet I point to the notion of the Arctic Ocean being the dominant ocean in the period of beta. And that is in a quick nutshell, that is my answer. And because as the Earth changes in its temperature, its amount of ice cover, and therefore as to which ocean is active and not active, I will make this comment that the flip, or let's say the change in frequencies, if we look at alpha, beta, and gamma, First, there was no dominant frequency that we can necessarily see in that frequency range. We then see a period of time of 2 million years of a 41,000 year period cycle. And then we switch abruptly to a 100,000 year cycle in region gamma. And I make the observation among control systems aficionados or people who study this, the chain jumping from one limit cycle to another limit cycle, this is entirely plausible and it happens all the time. And again, that reinforces. And so to answer your question, I have speculated, but I'm on shakier ground or on thin ice, and that's a metaphor there, or a little play on words. I'm on thin ice when I make that, and I would invite being wrong if somebody can prove what caused the 41,000 year cycle. But I assert that it is internal to the Earth, and I assert that it has to be related to the oceans. Even when I first studied the notion of ice ages and the role of the ocean, came to me in an instant in my mind that if you're dealing with something with, say, a 41,000 year cycle or a 100,000 year cycle, that you have to have a large capacitance. And the capacitance, I said, of the thing that had the capacitance of the time constant was the matter of the oceans. And therefore, I knew that I was very confident that the oceans were the key to understanding periodic ice ages.
Any other points you'd like to make before we wrap up?
If there's any point, it's related to the issue of the whole debate over global warming and climate debate. And should we as society stop what we're doing and cease the use of internal combustion engines and all this stuff? It's hard for me to take any of those debates seriously. They are not based on science. They're based on hysteria. I just don't take it seriously. If people, and I will also say this, why has the meteorological climate community failed to explain ice ages, periodic ice ages? The evidence is very clear and it's in front of us. They certainly should be able to come up with an explanation. And in my opinion, they have failed because they are ill-equipped to handle the problem. They don't understand the mathematics of feedback control systems. They've never heard the name of A.M. Lyapunov before. They don't understand limit cycles, and that they have just jumped on a certain assumption and they've gone down a certain road path saying, hey, we're correct. And the world has to obey them and listen to what they're saying. They have not solved the problem because they are not equipped to solve that problem. And I argue that the notion of Earth's ice ages, the whole topic, is an issue that is climate or that is feedback related. It is dynamic system. I claim and argue that there are very strong feedback loops at work. And if you do not have the background and the strength and the fluency in the mathematics of feedback control systems, in particular, the work of A.M. Lyapunov and nonlinear systems, you will not be able to solve the problem. You have two ways to then solve the problem. You can either invent the mathematics from scratch and say, hey, I really need this body of mathematics, or you can go to the existing literature and say, hey, it's all over here, open the book and we can read about it. I would invite being involved in discussions with other researchers as much as can be. I publish the one book, Shivering. I'm looking for a co-author because being as 84 years young and being blind, I just can't do the manuscript work and do the research. I would love to be able to come up, even though I've said simulations aren't worth doing, I'd still love to do a simulation. I asked my son, who has a doctorate in experimental physics and is an oceanographer, and he said, oh, Dad, that's interesting. He said, well, I'm a little busy today. And so, but I just have not, let me say it this way, that I'm having a wonderful life. I don't wake up any morning and say, oh, there's nothing to do today. I'm just having a wonderful time, and I've enjoyed the opportunity to present this material. And I thank you for your time and attention.
All right. Thank you very much. You're exactly the type of guest I was hoping to have on this podcast. Thank you again, Richard E. Klein.
Good.
Talk to you later.
Thank you, Tom.
Yep. Bye.